I'm Chirag, Chirag Agrawal. I'm working at Novelis. I'm a data science manager over there, and mostly I'm working um, on advanced predictive maintenance solutions for Novelis. So, a brief background about the company. So Novelis, it's a leader in flat rolled aluminum products and recycling. It has more than 12,000 employees globally, located in 9 countries, with 33 manufacturing sites, and with annual revenue of more than $17 billion and EBITDA of $2 billion. And two fun facts about the company is last year we recycled 80 billion cans, and aluminum product or aluminum Novalis aluminum features in 225 car models. There are four customer segments for the company. The major one is beverage cans, followed by automotive, aerospace, and specialty. So these are the four main business segments, and there are all business. These are the business partners for Novalis. For roughly around 4 years ago, companies started getting into utilizing the data, and that's when the company has basically built. So I'll kind of give you a little bit of workflow about the digital team that we have at Novalis and the way it works. So we basically have a list of, like, we find out the business problems, and at this point what we are doing is we are mostly working on solving the operations problems in the operation area. And so we basically connect with all the process engineers, automation engineers at the plant, find out their business problems, and then once we have a good understanding of the business problem, then we see what kind of data we have. Then we get into, like, we plug in, like, the data science basically plug in with the business and start developing the proof of concept and show the value at a smaller scale. So basically working with the CSVs, flat text data, etc., and then create the model and show the value. And after that, once we show the value through a POC, we plug in the other teams, for example, in this case, data engineers, which basically start working on building the reliable pipelines, whether it is a local solution like on-site solution, or whether it is a solution which is from the data lake. So based on the different requirement, the pipelines are built by the team. And at the same time, there is another major role of regional digital leads. They come into the picture, they start giving training to the end users that, okay, we have a new solution which is kind of built. What should be the processes around it so that the solution is sustainable. So they make sure that, okay, the solution is there and we are capturing the value from the solution. So that's so far about the Novalis and the digital team. Now I'll talk about the use case that we had at Novalis. We were finding it very hard to meet customer orders, and we had problem in meeting on time in full customer orders. And the one of the problem that was identified was that we were having a lot of unplanned downtimes, and we through brainstorming, we thought, okay, we can reduce the unplanned downtime by adopting advanced predictive maintenance. So that's when we started looking into like utilizing the sensor data, and then use that data to find out or to basically predict when the component of the machine is going to fail. So with that initial problem, we had some initial challenges that came up. And the first one was the complex machines. We had a huge, very, very complex machines. There are like 2,000, 3,000 sensors on each of these machines. And they capture data at very high frequency. For example, if I just give you an example, one example of one of the machine, every 1 second we get like 100 data points just from one sensor. So just multiply that by 2000, 3000 sensors, and you get that amount of data that what we are dealing with. So and it's not just the high frequency data. Also, when we were building the data science team or the digital team, we did not have the understanding of the data. We did not have that knowledge base which we could use and utilize this data. So that was one of the major challenges. The second challenge that we had was, okay, if we create a solution, how good people like the engineers and users at the plant, whether they will trust it or not, because a lot of these predictive maintenance or the advanced solutions, they use algorithms and they are very complex in maths, so it's very hard to understand that. And it's kind of a black box for a lot of engineers. So that was another challenge. The third challenge was whether we want to build it in house or we want to go with the external partner. So we basically wanted to evaluate whether we have the right expertise within the house, within in house or not. And the final was site evaluation, which is like which machine center we should pick up for doing the proof of concept. Do we have the right resources available to support the POC? Do we have the right set of data available to do the POC? So those were some of the initial challenges that we had to overcome. So to with that, keeping those initial challenges in mind, we kind of built a roadmap for the solution. So this solution was ever evolving. So what we did was we first created an internal solution, which was a like quick proof of concept utilizing the rule based signals. So we basically went one signal at a time, and either we built the statistical models on top of it, or we built the rules based on the engineer's knowledge, and created the solution and deployed that solution on the critical machines. And we deployed that solution on two machines, and uh, it created a good value for the company. And we onboarded the executives as well as the engineers, because now engineers, they understand the rule based solution, they understand the statistical based solution. The executives were happy because we showed the value that, okay, this utilizing data, you can create the value for the company. So every entire team was onboarded. So we went ahead and started using the basically external solution. And we selected a vendor based on a criteria. And then now we are working on that solution. And at the same time, we are not just like building the solution, but at the same time we are developing those processes so that we can sustain the solution. Generally, I have seen in my experiences that when we do a data science project, we go with the 10 data science project, but ultimately we realize value from maybe 2 or 3 projects, sometimes even like 1 or 2 projects. So that's where we have to basically start with that. Okay, if we do not have the right set of processes laid down, or if we have not defined the RACI chart, which is who is responsible for the processes, who is accountable, who is consulted, and who is informed, then after probably 6 months or a year, it will be hard to sustain that solution. And that solution, all the investment which are made, they will die down after a time frame. So it's very important to define those RACIs, measure KPIs, and then finally always have a dashboard which measures your KPI. So this is what the end solution looks like. So we had the assets on the left side. So we are capturing the data, and these are all high frequency data. So we are using historians to capture that data. Then we are sending this data to the cloud. Over there, we are doing the pre-processing. So we are basically downsampling the data. We are doing the data quality checks. We are performing exploratory data analysis, and we're doing bunch of different aggregations over there. We are creating new features or derived features from that. Once we are ready, we know we have good confidence in the data. we are sending that data in the engine. Now, engine is a hybrid engine. It's not just only algorithms or only rules or only statistics. It is mix of all, because what we are trying to do, what we have seen in the past, not just like this project, but the other projects as well, that we get a lot of false positives, or sometimes we miss the right alert as well. So we want to make sure that we are basically doing a hybrid approach, so that we are getting the quality alerts. So once the data goes inside the analytics engine, it comes back, it generates the alert based on the anomaly. So what we are doing here is we are not feeding one signal at a time, but we are feeding multi-variable. So we can basically think about like we are feeding in 200, 500 signals in the model. It is going through bunch of different layers. And then what we are getting in the end are alerts or forecasts or health score. Now, further, these alerts are combined with FMEAs, so that we know what action we have to take, or what action the end user have to take. So that is basically the advisory. And we are not just giving it like not just a one-way traffic, it's the other way as well. Once they get the alerts, once the engineers they get the alert, they can provide their feedback that okay, was it a good alert, it's a bad alert, and we capture that feedback, improve the engine, and then we keep iterating over that process so that the entire process is stable. This is almost again the same thing. Like we have the engine built in, we got the top sensors which are contributing factors. Based on those sensors, we are combining that with FMEAs. We are finding out the top reasons like why we are facing the problem, and based on that, we are generating the advisory for the user. So I'll just run through like how the final solution looks like. The end user or the engineers, they get the email. And this is what it looks like, which model generated the alert, what are the causes, what are the recommendations. Like basically they get all of everything in their plate right there in the from that notification in the email. If they want to go check on the dashboard, they can click here on the view alert, and it will take them to the dashboard. This is how the dashboard looks like. Once they go to the dashboard, they can see what is the model, what are the causes, what are the recommendation. They can also see the occurrences. Last 5 days or last 2 days, how many times the same alert was generated. So that way they can combine all the alerts together, and it's just not like multiple actions are not required on the similar type of alert. Then the alert analysis can be done right there. So basically, it shows that okay, what was my cutoff for the anomaly score? So this is where the feedback loop is very important, because if we are not getting the feedback from the end user, we don't know what cutoff or what anomaly cutoff we should keep, and that is important because that's what generates the alert. So if you want to reduce the, let's say, false positives, we probably want to bump up the cutoff. So these are the alert analysis, and then this is the alert assignment. So once we know, okay, this is a good alert, the person who is reviewing the alert, that person can either assign it to someone or whether keep it to himself. And then also there are a bunch of other things that the person can do, whether he can attach to the attachments, write the comments, and all of this is available in history. Benefits. So this solution is still work in progress. We are working on that solution, but with the POC, we already proved that it reduced 8 hours of unplanned downtime per month, and it reduced the end product, the 4 coils, scrapped coils per month, and which was like a good amount for the company on an annual basis. Um, and all these numbers were verified by the finance, so they are like realized profit for the company. The full-blown solution that we are currently working on, we are expecting a huge amount of saving for the company, and also increase in the asset life, as well as like less workload on the for the engineers, as well as like less product defects. And finally, lesson learned. So data is a new oil. So use data for it. It's basically a strategic driver for the company. Use your data to get better insights. Uh, Second is change management. Uh, any solution you develop, because that's a new solution, it's very hard to push that solution for people to adopt it. So you have to work around it. Like, you have to make sure that you're including your end users. You should know who are your end users, include them into the solution, give them the right set of training, because that is very important. If they are not onboarded, your solution, how good it is, it will not be used. Creating the race C chart, which is very important. Should know, okay, who has to take what kind of action. If we don't know who has to take action, we have the solution, no one knows what to do on that. The solution will again fail. There will be no adoption. Hybrid algorithm, I put that from data science perspective, because this is very important to reduce the false positives. If you want to improve the accuracy, you want to include bunch of different types of algorithms. You want to include statistics. You want to include physics, thermodynamics, anything, so that you have a better alerts. And finally, stakeholders. Your stakeholders are many. Don't always think about your end users. At the same time, think about the executives who take the decision. Because in the end, if your product is not showing the value, I mean, if you invest $1 million and if you're getting 10x results, probably they're not happy. So build a KPI dashboard for each of your customer. And that was my last slide. Thank you.